Hi, my name is Jenna and this project is part of the Pimp My Bike series. In this video, I'm going to show you how to build turning indicators and a strobe nightlight for your bike. For more information, check out my website, jdubois.com. Let's start by talking about the materials needed to complete this part of the project. You can find links to components on my website. First, you're going to need an LED matrix panel produced by Adafruit Industries. You're going to need 2 LED push buttons, also from Adafruit Industries, roughly 6 male and female connectors, a handful of male, and male-female jumper wires, a proto board for the circuit at the back of the bike, 2 10K resistors, and finally heat shrink tubing. You're also going to need a variety of tools: soldering iron, solder, wire stripper, wire cutter, and pliers. Okay, let's begin by talking about the push buttons, which are used to control the LED display. The LED ring is a nice feature because you can light up the button when the turning indicator is in the on state. There's an internal built-in resistor, so to light up the button, you simply attach the negative pole to ground and the positive pole to an analog or digital output pin on the Arduino. The remaining 3 poles are for the button. Let's take a look at a circuit diagram for a switch. This switch is currently in the open state. If we were to read the voltage with digital pin 2 on the Arduino, it would return low, or 0 volts. When the button is closed, the voltage at pin 2 is high, or 5 volts. A normally closed button is closed by default and is open when pressed. Conversely, a normally open switch is open by default and is closed by applying a force. Looking back at the button, you'll see that the poles are labeled NC, NO, and C for normally closed, normally open, and common. Here's a diagram for how we're going to wire the LED push buttons. To light up the LED, the orange wire connects the positive pole to one of the Arduino's output pins, either digital or analog, and the minus pole is grounded. For the switch, the NO pole is wired to 5 volts and the common pole is wired to a 10K resistor, which is grounded. We use one of the Arduino's input pins, in this case digital pin 10, which is connected to the blue wire, to sense if the button has been pressed. We built this circuit on a proto or screw shield that snaps into the Arduino, and we connect the push buttons to the circuit using 4-wire male and female plug cables. Here's how you attach the push button to the cable. First, you strip a little bit of plastic off the end of the connector. Then you slide some heat shrink tubing over the wire and thread the wire through one of the poles on the button. Twist the wire around itself to make sure it's nice and tight. Make sure not to forget the heat shrink tubing. And then you solder the wire to the pole. Slide the heat shrink tubing over the metal and shrink it using the end of your soldering iron. You're going to repeat this process for the remaining 3 wires. When you're done, snap the male-female connectors together and mount the push buttons on your handlebars. Okay, now let's talk about the LED matrix panel. Thanks to Adafruit Industries, this part is pretty straightforward. You can check out their online tutorial for additional information, including a wiring diagram. You'll have to add the HT1632 matrix panel library to your Arduino sketch. You can get this library from GitHub. There are 5 wires that need to be connected to the panel. 1 to 5 volts, 1 to ground, and 3 for controlling the display. For now, just note that 3 of the wires from the LED matrix need to be connected to the Arduino. I ran male-female connectors down the length of my bike to a proto board on the back. Ground and 5 volts will come from a lithium polymer battery stored behind the matrix panel, and the 4th wire of the 4-wire connector will be attached to the brake potentiometer. We'll discuss this circuit in more detail in another video, but in case you're curious, here is a circuit diagram. Finally, I'd like to just mention the LED Matrix Visualizer, which is a processing sketch that I wrote to make it easy to design your own patterns for brake lights or turning indicators. You can find links to the processing sketch on my website. And that concludes this video. Thanks a lot for watching. Feel free to check out my website, jdubois.com, for additional information and videos.